So back to the conversation about control objects. Control objects are simply objects that manage other objects. For instance, a collection, such as an array list or hash map or tree map, or simply an array, a more primitive array of objects, of other types of objects. These are good examples. Any kind of collection or sequence would be an good example of something that manages other instances of other classes, would be a control object. Another good example of control object, of course, would be a controller of a use case. When we discuss model view controller, that we would like to impose restrictions on the structure of our relationship between multiple tiers, such as user interface, which is the presentation tier, then the business object tier, and we would like to have controllers that separate these two groups of objects. You can have other control types of objects. For instance, I already mentioned database connection. Database connection object, it manages a resource. So therefore, as soon as I begin to say something like manages or organizes, or you can have the whole series of control objects which create other objects. We can designate them as creator objects that help to create other objects. These are also objects that manage other types of resources in the system, so they would be qualified as control objects. So I should say that you should probably feel the difference between the roles and responsibilities, for instance, of a use case controller versus parcel of land, which is a controller is much less dependent on our business domain, because you will find use case controllers in almost any application that has non-trivial set of business objects and equally a non-trivial user interface, versus the land parcel, which would be kind of specific to this real estate management system domain and not so much specific to maybe healthcare or some other areas, right, or science, right? So there's definitely difference. They're all equally important. We all need these type of classes, but still, this type of category, realization of category and understanding of categories of classes that you create is important, because to model, design the structure and behavior of entity objects, you have to have more knowledge of the specific problem domain, whereas if you work with interface objects and control objects, you need less knowledge of that, because they're more of an application architectural structure level, and they're more universal across multiple problem domains. So anyway, how do we identify things? How do we find things? What type of decisions we make? For instance, tangible objects. Tangible means physical, something that we can essentially see or understand, like a planet or star or asteroid, right? With all of their physical attributes and elements, they're pretty much tangible object which can be modeled directly as we understand the math and the physics and those type of things. Descriptions and specifications, for instance, in our case could be, I'm thinking, the property owner could hold a title. Let me just switch to a different color, right? Some sort of title or deed. Right, so that would be, or the property owner could hold a certificate of some kind, like some municipal certificate that certifies, a level of inspection or something else, right? So these types of things which simply iterate certain attributes that have to satisfy certain, regulation, condition, or something. So these would be an example of specification or description. Another situation which would qualify as specification, for instance, you can have a game application, which is like a video game, and it needs to describe its layout or configuration, right? So of course that would be the level of description or specification. Places, so these are kind of natural, other type of things that would suggest creation of objects. So places, I'm thinking, I don't know if over here we can maybe an address qualifies for places, as we move along, we may find more examples in our presentation. Transactions, right? So transactions, when we say transactions at this level, because we're really starting with this really high level of search for useful things that would eventually materialize as useful classes. Transactions are things, basically the processes, the updates, which may be, create, delete, modify, change, sometimes swap, but combinations of changes that have to be occurring as one unit, right? So these are transactions. We say that elements of the system are transactional. The classical example is like money transfer from checking account to savings account, right? You want to withdraw the money and you want to deposit the money, but you don't want to lose track of these two parts somewhere in between, because then it becomes invalid transaction, right? So transactions are essentially combinations of actions, changes, updates, modifications, which have to take place as a single unit, right? As a single atomic instance, as opposed to be scattered around in time and space in your system. So transactions are often very useful to be programmed as one class. And in order, for instance, to make your money transfer, first you create a transaction and then begin to use methods of that transaction. The roles of people, institutions, devices, and so forth. In our case, right, the property owner would be an example of the role of a certain, certain entity in the world that plays the role of property owner, right? So that's the role of certain entity. And again, this can be an individual, right? Individual could be individual, but then as you begin to think about individual, what do you do with the spouse, right? Usually the spouse could be also the owner or co-owner. So immediately you have to decide how does that impact what you do, for instance, institutions could be the property owner, right? So the property can be owned by the bank, right? The property can be owned by some sort of trust, right? So people could form a trust and say they own a property, or it can be a non-commercial organization, right? Some sort of organization that is goes by the laws and statutes of non-government, non-profit type of organization. It could also be government organization. So the different types of things can play the role of property owner, and like I said, this kind of gives me a rich set of examples to give you. So there, containers, right? Another type which is quite natural, right? Array list. It would be very difficult to program in Java without an equivalent of an array list. But in the first place, array list is a class. And it's a container class, and it can be used to contain other types, to form collections, and therefore, it's a special type here. However, we sometimes need to define our own collections, right? Sometimes you want to create your own collection, and I'll give you an example. For instance, you're programming a video game, and you have virtual characters moving around the scene, and but they all need to act as a group. They need to be aware of one, other's location, state, and so forth and so forth. So you may have instances of objects like this, which you may want to organize into a list like this. So they're all sort of like interconnected, and if you want to add a new character to this picture, what you need to do, you have to insert it into this circle or circular list of things, so that then anyone here can say, I would like to communicate with someone else. And if there's something important going on, they basically send a message to the next object, which will digest the message and then send it to the next one, and which in its own turn will be digesting and sending it over. So this way, all of the objects have a chance to communicate, and this instance, this object right here, who actually initiated this message in the first place, will be able to detect that he or she or it is actually the source of that message, and therefore will no longer forward it to the next element on the circular list, right? So you may, how do you actually create something like this? You could have just an array list of all of these objects, right? So there could all be over here, and all of this intercommunication you can model by simply iterating through this collection and emulating this connection between them, because they're all placed in the same collection. Or you can organize them such that each one of them is basically an element, the node on the actual list, which has the reference or the pointer to the next object, and so there actually are forming this type of list, circular list in my case, for the reasons of communication between different objects. So you can think about this type of organization as custom to your application, and therefore you can define your own containers and collections, like lists and so forth. Sometimes you just need that. Sometimes it's difficult to pick a good standard library type of collection for the type of activity that you would like to have and in your system, and that would be your choice would be to define your own type of container or collection or sequence or list and implement it. That's typical in all non-trivial situations.